Okay, so let's graph parabolas. So we have two types. X squared is 4py or y squared equals 4px. This will work basically for both of them, but we'll do one example of each. Sorry about that. So let's say that the formula that we were given is x squared equals 12y. Okay, so step one would be to figure out which of the two types do I have. Well, this is an x squared equals 4py type. Okay, what that means is that the x squared is being squared, so it runs in the vertical direction. Okay, you can just look at the squaring part. So if the y was being squared, then it would be a horizontal direction. And then you look at the 4p. Well, we know that 4p in this equation has to equal 12. Divide by 4 on both sides, that makes p equals to 3. That's important because it tells you whether the graph is going up or down. So in this case, vertical, p is positive. Hopefully that makes sense then, that we're going to say that this one goes up. So that's generally what we think of as up as being positive and down being negative. At that point, I generally start making a little sketch, or not some, well, yeah, this is probably not going to be a whole lot better than a sketch. So, but I'm going to put my vertex on my coordinate grid, and so I'd like that one to be a little bit bigger. Okay, and we know that for all of these, the vertex is always at 0, 0. Okay, we'll work on the non-zero zeros later. And then the 3 also tells me a little bit about my focus and my directrix. So if it's 3 and we're going up, then we know that your focus must be over here, because your focus is always in the direction of opening. And that means that the directrix would be at a -3. So this is going to be a little bit harder to draw straight by hand. So here is your directrix. Okay, then we would really like to get a couple more points. With these types of parabolas, we're probably going to have to just settle for 1 or 2 more points. So if you're not sure how this thing runs, just make a table. That's a good strategy for anything that you're graphing. So here's the table, and then pick a point. Well, a lot of times we pick 1. So let's plug in a 1 here and see what happens. So if you have a 1, you square it, and then so you get 1 squared is 12. So 1 is equal to 12y. So then y would be 1 over 12. Well, that's really difficult to graph. So you're going to have to play with numbers a little bit. So let's see what would happen if I pick a bigger x, so that if I make my x larger, the y value become a little bit more reasonable. So let's try 4. So if I square 4, you'll see I get 16. And so the reason I picked 4 is because I knew that 4 squared was going to give me a little bit more than 12. So that now when I divide it out, I get 16 over 12, and that is actually 4/3. And although 4/3 isn't going to be 100% accurate, at least I can graph a point that is slightly more than 1. So I go 1, 2, 3, 4 in the x. I should be slightly above 1. Well, the cool thing about parabolas, though, is that you have symmetry. So if 4 to the right gives you up 1 and 1/3, then 4 to the left would give you the same y location. So both of those points must be on there. And then at this point, we're just going to graph the parabola. So notice that the parabola like this is going to be very, very flat. Wow, and I really missed it on this side. We're going to cheat, so now it actually hits the graph. It hits the graph. Hopefully when you draw this with pencil, you do a slightly better job, but that's it. So, thank you.